Hello students, in this video we'll see an example of how we maximize the product of the sine of angles in a triangle using Lagrange multipliers. So our problem is that we're going to suppose that a plus b plus c is equal to pi. So a, b, and c are the angles in a triangle, i.e. a, b, c are the angles in a triangle. Okay. And I want to find the maximum of sine of A times sine of B times sine of C. Okay, so this exactly tees up our Lagrange multiplier method, so let's do it. So here's my function f. This is my function f of A, B, and C. And this is my constraint function g of A, B, and C. So by Lagrange multipliers, the Lagrange multiplier method tells us that the gradient of f is lambda times the gradient of g. So let's compute the gradient of f. So the gradient of f is going to be cosine of A, sine of B, sine of C, and then sine of A, cosine of B, sine of C, and then finally sine of A, sine of B, cosine of C. That's my gradient of f. And now my gradient of g is just going to be what? It's going to be lambda times 1, 1, 1. Okay? Now from this we can conclude that each of these three expressions are equal to each other, right? So this expression is equal to this is equal to this, so any three are equal to each other. So if we compare any two of them, we can get some conclusions from this. So one thing we can do is we can look at, we can say, for example, that the cosine of A times the sine of B times the sine of C is equal to the sine of A times the cosine of B times the sine of C. That's one thing we can say over here. And so of course, since the angles, if one of the angles is 0, we don't have a triangle, we can cancel out sine of C from here. And the conclusion is that since we can't have C being equal to 0, since we're actually in a triangle, we're going to assume we're non-degenerate as well. We're going to have the cosine of A, the sine of B, minus the sine of A. The cosine of B is equal to 0. And of course, what does this say? This says that the sine of B minus A, this is exactly the formula for the sine of B minus A. The sine of B minus A is equal to 0, right? And so the sine is equal to 0 at 0 and pi, for example, in the natural domain of the inverse sine. So this is going to force what? This forces A minus B either to be a multiple of pi, which is impossible, or it forces them to be equal to each other. So this condition actually forces A to be equal to B. And by symmetry, we have A is equal to B, and then the same thing is true for C. So all of them have to be equal, which says that each angle is pi over 3. And so this implies that since A plus B plus C is pi, this implies that A is equal to B is equal to C is equal to pi over 3. So our triangle is equilateral. And then what will the maximum value be? So I'm going to have the sine of pi over 3 times the sine of pi over 3 times the sine of pi over 3 times. And so each of those things is root 3 over 2, so root 3 over 2 quantity cubed. And so that will be a 3 root 3 over 8 is your maximum value of this function if the angles add up to angles in a triangle. Thank you very much.